Okay, we're going to talk about exponents in this video, as you've been working through the exponent section of our number sense unit. Um, really, all exponents are a way to quickly write repeated multiplication. So if I have 3 to the power of 4, that's the same as doing something that we've always known how to do, which is multiply 3 4 times, which is 81. It's just quicker to write it as an exponent than it is to write it as repeated multiplication. But it's really nothing new. The two or the three words that we need to know kind of the vocabulary is this number, the large number we call the base. That's the number that I multiply again and again and again. And then the exponent, the small number to the right, which we write in superscript. That's when we shift the font up to the top. That's the instruction. That tells us how many times do I multiply. So the exponent is telling the base how many times to multiply itself. And all together we call this a power. So we could say 3 to the fourth or also 3 to the power of 4. That's just the vocabulary behind it. So when I say write in expanded form, so different instructions that I could give you. Write in expanded form means that I want you to write as repeated multiplication. So expanded form means repeated multiplication. If I say evaluate in math class, you're going to see all the time. That just means, okay, tell me the answer, which again, you should be able to do on your calculator, 5 to the power of 3. If you're having trouble finding the exponent button on your calculator, let me know. On some calculators, it looks like a hat. On other calculators, for example, the iPhone or an Android, is going to look like, the button's going to look like X to the Y. And you always press the base first, then you press whatever the button looks like, and then you press the exponent. So it's pretty simple when the base is a positive whole number, like 3 or 5. We can, in some of the practice problems you're going to do today, we could have a base that is a fraction, and there's no problem with that. That means 2/3 is our base to the power of 4. Again, all this means that I've got to multiply the base by itself 4 times. Remember that I don't need to write the multiplication symbol in between. This just means I'm multiplying 2/3 4 times. And when we multiply fractions, it's just top by top by top by top. So it'll be 16 over 3 times 3 times 3 times 3 on the bottom is 81. So fractional base isn't an issue because I can do 2/3 to the power of 4. Another way to think about that is because I'm multiplying top by top by top by top, that's also the same as saying 2 to the 4 and 3 to the 4, right? Because the bottom 3 times 3 4 times is the same with 3 to the 4. So that's something that's true in general. Doesn't matter what my fraction is, 5 to the 7 cubed, that's the same as 5 cubed over 7 cubed. So I'm kind of distributing my exponent to the numerator and the denominator. So that's one thing that might help you do a couple of the homework questions. Similarly, if I have a negative base, so let's do -8 cubed, that means I've got to take the number -8 and multiply it together 3 times. So everything in the brackets is part of the base. 3 negatives, well, my answer is still going to be negative. And then 8 times 8 times 8 is 512. So when the negative sign is inside the bracket, it's part of the base. And then I have to get to the power of 3. So if I have an odd number exponent, I'll have an odd number of negatives. So my answer has to be negative. If I have an exponent that is even, this means I'm multiplying 4 negative numbers together. So my answer is positive. And then 2 to the 4 is 16. 2 times 2 times 2 times 2. So be careful with that. An odd exponent of a negative base is going to give me a negative answer. But if it's even, an even number of negatives will still multiply out to a positive. It also, one thing to be careful about is it really matters whether this negative sign is inside or in front of the bracket. So -2 cubed is not the same. I use this equal sign with a slash through to say not equals as So these are going to look a little bit different. In this case, the answer actually is going to be the same. So maybe we can say is equals. Let's look at another example. I'll just kind of explain this a little bit slower. Negative 2 squared is not equal to negative 2 in brackets squared. So let's look at these on our right side there. I've got to do negative 2 times negative 2, which is positive 4. Here, however, remember that exponents in order of operation comes before subtraction or multiplication. So I'm only going to do 2 to the power of 2, which is 4, and then I still have the negative sign in front. So if the negative sign is in front, it's not part of the base, only if it's included in the bracket. So you want to be really careful about that. One last example, which I think might come up on some of your, towards the end of the homework, some of the tougher problems. If I have 2x cubed is not the same as 2x in brackets cubed. So 2x cubed, that's already simplified. But if I have 2x cubed, where again, that everything in brackets is the base, that's going to be 2x times 2x times 2x. 2 times 2 times 2 is 8. And then I've got x times x times x is x to the power of 3. So it does make a difference. The exponent is only attached to the number or the variable directly next to it, unless everything in the base is part of brackets. So that's something to be on the lookout for as you do our problems. The other thing that you've gone over in the course content, which maybe I'll just cover briefly in this video, is we learned the start of our exponent rules. So exponent rules, the first one we learned is that if I'm multiplying powers with the same base, so for example, x cubed times x squared, then if I'm multiplying powers with the same base, I add the exponent, so 3 plus 2, so my answer would be x to the 5. And the reason that's the case is x cubed, well, that's just the same as x times x times x. And then I'm multiplying it by x squared, which is 2 x's. So really what I'm doing is I'm multiplying 5 x's together. So I have x to the 5. So that's the explanation of why I need to add the exponents when I'm multiplying powers that have the same base. Same idea when I'm dividing. So let's look at x to the 6 over x to the 4. And you learned in the course content that when I'm dividing powers with the same base, and a fraction just means divide, I'm going to subtract my exponents. So it's going to equal x squared. And again, we kind of look at the same logic. X to the 6, that just means x multiplied by itself 6 times, divided by x multiplied by itself 4 times. But if I divide something by itself, the answer is just 1, or it cancels out. So x and x cancel out. X and x cancel out. And I'm left with, again, 2 x's multiplied together, x squared. So that's kind of the explanation of where that rule comes from. Why, when I'm dividing powers with the same base, I'm going to just subtract my exponents. So that's sort of the second thing that we learned in our content today, and hopefully this video is going to help you as you approach some of those practice problems that you're going to work on now. And if you have any questions, again, please shoot me an email or just leave a comment on this video. Okay, thanks for watching again.